Okay, we're talking now about 12.2. This is a very exciting chapter on pyramids. So let's look at some of the harder homework problems that I gave you. One of the ones that might be a little harder is figuring out the lateral area of a regular triangular pyramid. If it's a regular triangular pyramid, then the base of this guy is an equilateral triangle. So there he is. I draw my triangle, and then I draw the point above it, this vertex, this apex that comes and meets the base at a right angle. How do you like that right angle? And I just fill in the blanks there. Okay. Now, so there's the picture. Lateral area is equal to 1/2 the perimeter times the slant height. Remember, L means slant height, right? L is slant height. Okay, so let's see what we have. We're given that the base edge is 4, and we're given the slant height is 6. Okay, so this is pretty much of a plug and chug kind of problem. I might make this a little bigger here. Still nice and focused. Good job. Okay, so the perimeter, it's all the way around. If each of these edges is 4, 4 plus 4 plus 4, or 3 times 4, 1/2 the perimeter, 3 times 4 times the slant height, 6. All right, when you do the math, it's 36 units squared. So that's that. Number 8, let's look at this one. This time we are given a base edge of 12, a lateral edge of 10, but instead of a triangular pyramid, we're given a regular square pyramid. Okay, that's good to know. All right, so there's the picture. I draw it. There it is, beautiful picture. There's great instructions in the book on page 485 in the middle showing you how to draw these things, so I'm not going to take the time to do that. You can just read that. Figuring out the lateral area, again, the formula is 1/2 the perimeter times the slant height. Okay, L slant height. As opposed to lateral edge, different thing. Okay, so what I want us to do here is I want us to look at a face, a triangular face of this pyramid. Now remember, the faces of all pyramids are isosceles triangles. So there it is. I'm looking at that and redrawing it here. Okay, and I know that the lateral edge is 10. So this edge right here, this edge right here, this edge right here, this edge in the back, those are all 10. There it is. Okay, and I know this entire base edge is 12. So this guy is 12. So I know for an isosceles trapezoid, what am I saying? An isosceles triangle, if I drop an altitude from the vertex, this is the midpoint, right? We know that. So if this entire length is 12, then this distance from here to here is 6. And of course, if I need to find this height of the triangular face, the lateral face, you can see that this is 6, 8, 10. This is a Pythagorean triple triangle. It's just a multiple of 3, 4, 5. Okay, this 8 is not this dimension. It's not the height of the pyramid. This 8 is the slant height. So the slant height is 8. All right, now that I have that information, 1/2 the perimeter, okay, it's 12 all the way around times 4. There's 4 sides, 12 times 4 times the slant height of 8 that we just figured out. Okay, so when the smoke clears, I get 192 units squared. And that is that problem. Let's look at the last problem here. Number 10. Number 10, we have a very exciting regular hexagonal prism. So I start with a hexagon on my base. I get myself an apex or a vertex at the top, and then I just connect the vertex to these vertices of the base. These are the lateral edges, and dash the ones that you can't see. All right, so there it is. The lateral area is 1/2 the perimeter times the slant height. What I'm told is the base edge is 10. There it is. Remember, the base of any pyramid is an isosceles triangle. So here we go. Here's my isosceles triangle. So I just took this guy and I redrew this down here. The base edge is 10 and the lateral edge is 13. That makes this a midpoint, just like the last problem. Are we getting a little bored here? Is this too much the same? This is a midpoint, so this dimension is 5, and then this height of this face, this lateral face, 5, 12, 13, an exciting Pythagorean triple. So that's good to know. This 12 is the slant height. The slant height, remember, is different. It's not the height of the pyramid. It's the height of a isosceles triangular face. Okay, now I know the slant height. Okay, so there it is. Plug it into the formula. 1/2 P times L. My L is 12. Okay, 1/2. The perimeter, each base edge is 10. I have 6 of them because it's a hexagon. 6 times 10, 60. 60 times, let's see, 12 is divisible by 2 6 times, so 60 times 6, 360 units squared. So that is it. All right, done with that. Okay, how do I get this turned off?